Good morning, everybody. This is Mark Murbach from the NASA Ames Research Center. The title of our poster is System Design Considerations for a Small Venus Entry Probe Mission. The team has consisted of myself, Ren Johansson, who's kindly organized this for us, as well as our compatriots from San Jose State University, Dr. Papadopoulos, our colleagues from the Breakthrough Initiative, as well as some of our fine Stanford students. What are we trying to do? The question is whether we can use a near space launcher such as the Rocket Labs in order to deposit a small atmospheric entry probe into the atmosphere of Venus. So why would we want to do this? So the big question is, at roughly 1/6 of the mass of the Pioneer Day probe, what can be done in order to make some very interesting measurements in the 70 to 40 kilometer altitude band? What kind of instruments could we include and power and get data back in order to make this relevant? Lastly, if that were to be done well ahead of some of the larger missions that are going to be executed in this decade, such as Da Vinci, Veritas, and Envision, how would a smaller mission like this contribute? So the first part of the exercise then was to really look at SWAP and COM. So size, weight, and power and COM. Can you do this at these rather austere mass limits, roughly 15 to 20 kilograms? So we focused first on COM and found that we could close the link if the trajectory was such that Earth and Venus were in close proximity, such as the Pioneer concept of operations. And then we moved on to look at the aeroshell. So the mission itself is essentially a 3U nanosatellite with an appreciable power system and RF subsystem that is enclosed in a rather appreciable reentry heat shell to sustain the 10.5 kilometer per second entry. So we took a look at this, and then we started to look at the legacy in the trade space. First in detail with the Pioneer Venus, of course, but it turned out in order to tailor this for a shallow entry angle and small ballistic coefficient, then we were forced to look at some other considerations. The other legacy one is to look at the stardust. So we were looking at a 60 centimeter shoulder stardust capsule that was austere, but it appeared to meet some of the necessary qualifications. Depending on the risk posture, we could also go to a TDRV style probe with transpiration cooling, or a drag device that we're developing as well. But both of those are riskier and would require a GTO flight test experiment that we're contemplating. With that, I will open this to any questions. Thank you very much for your kind attention, and we look forward to interacting with you. Thanks again. Hope to see you in person next year.